Hi everyone, welcome to AIMS India's online classes. Today we are going to discuss language of chemistry in our chemistry class. Okay, this is Purnima, your chemistry faculty. Let us see the introduction of language of chemistry. See, what is language of chemistry? Before going to that, chemistry is the branch of science which deals with the study of chemical substances, what is their composition and what are their properties like. See, different types of branches of science we have, that is physics, botany, zoology. Like chemistry is also one of the branch of science. Again, in that chemistry we have a subdivided into different branches. Okay, what are those different branches of chemistry? See, first one is inorganic chemistry, like organic chemistry, physical chemistry, analytical chemistry, industrial chemistry, nuclear chemistry, biochemistry, nanochemistry, medicinal chemistry. Like we have a different branches of chemistry. Okay, again this is the subdivided branches of chemistry. Science, in the science, chemistry is one of the branch. Again in that chemistry, these are the different branches. Okay, see, generally we'll study about inorganic chemistry, organic chemistry, physical chemistry, and this industrial chemistry, nuclear chemistry, biochemistry. These are in different branches. Like, okay, let us start with what is the language of chemistry. See, chemistry and its language. Why we are studying that language of chemistry? What is chemistry's language? Like we are not studying a physics language like that. See, what is this language of chemistry means? Suppose when we start learning in our early stage, in our pre-primary stage or in primary classes, in nowadays that pre-primary is existing. See, first we starts with the identifying of alphabets. This is A, like this is B, this is C, like identification, and then learning how to write A, how to write B, and then words, and then sentences. Like that, in a part wise will come. First identification, and then writing, and then framing the words, and then framing the sentences, like will come in the order. Like that only, when we start learning the chemistry, we should know about its language. Suppose, see, we have a hydrogen, like hydrogen, HYDROGN. No need to write the complete spelling of hydrogen. Instead of hydrogen, we can use the symbols in chemistry, that is called H. While we are talking about carbon, C, aluminium, Al. While we are talking about water, in water the chemistry molecule is H2O, water molecule, like. So the learning of symbols and its elements and formulae of the compounds, and then equations, and then reactions. This is the order of chemistry. First we should know what is the symbol, and then element name. Suppose if we take one example of sodium. Sodium is there. What is the symbol of sodium? How to represent, how to write the formula, how to write the equations based on that, and then from the reactions. All these are the particular series to learn the chemistry. So what is that language of chemistry? Now we are going to learn. See, first of all, come to the symbol. What is meant by symbol? See, in mathematics, we have a different types of symbol. For addition, we will use plus. For subtraction, we use minus. For product in the sense for multiplication, into. For division, divided by, equal to, greater than, less than, greater than or equal to, root, sum of the, sigma we use, pi. So for everything we have a symbols, right? Like that only, even in chemistry also we have a symbols. For writing hydrogen, H, chlorine, Cl, like symbols. Even one more example also we can consider, that is a stenographers. In olden days there is a typewriting, so stenographer, but now the complete multimedia was changed and everything was changed. While the news reading also, while news collecting also, in the media people, they'll use the shorthand notations. because see, if they go to any one press conference, that they will speak so much, they'll give so much words or sentences, so they can't write everything, so they use the shorthand notations. Even the shorthand notations, what the stenographers they use and what the media people they use, we don't know. Those are the symbols for the shorthand notations. That is only the symbol we are calling. But these shorthand notations used by these stenographers are different when compared with the mathematics, the symbols we use. Okay, again that is one course, the learn that shorthand. Okay, see, let us see what is this. So there is a need of symbols also felt by chemists as science advanced. So instead of writing the complete name, complete compound name, we can use the symbols like they felt. In chemistry, a symbol is defined as shorthand sign for the full name of an element. Shorthand sign for the full name of an element. J.J. Berzelius suggested a method of representing elements using English capital letters. See, again while writing the symbols we have some rules. Suppose chlorine is there. Chlorine represents with Cl, but first letter should be capital, second letter should be small. Nitrogen is there, only one letter is there. Nitrogen we should use the capital letter. Carbon only there, carbon capital letter. Hydrogen capital letter. So what Berzelius suggested a method of representing elements using English capital letters. While writing the first letter should be capital. Whenever you are writing the second letter for the representation of a symbol, that should be small. Again that come under the rules and regulations while writing the symbols. Each element has unique symbol assigned to it. Yes, we have 118 elements. So everything should have a unique symbol. One is not supposed to coincide with the another one. Hydrogen means capital H. Capital H always should represent the hydrogen only. Chlorine means chlorine first letter is C. Again carbon is representing with C. Again while writing C, either it is the carbon or chlorine, not supposed to get confused. That's why it is clear carbon represents with capital C and chlorine represents with capital C and small l. So whatever the 118 elements we have, that 118 elements have a particular symbols which does not overlap with each other. Okay. Each of these elements has a symbol of its own. Every element has its own symbol. Example, see, the symbol or short form representation of element hydrogen is H. Whenever you are writing hydrogen with the quotations, that represents hydrogen like in chemistry. In chemical changes, when we write capital H, it means element is hydrogen like. And the symbol or short form representation of the element oxygen. Whenever you want to write the oxygen symbol, you'll write capital O with quotations, quotation marks that represents the oxygen. That represents oxygen. Instead of writing the complete spelling, you can represent with capital O. That means element is oxygen like we'll understand. Some elements were having their symbols from their Latin names also. What is this? See, sodium symbol is actually oxygen means first letter O we are considering. Carbon means first letter C. Like that only sodium means first letter S it should be. But sodium represents with Na. Where from this Na came? Actually sodium first letter is S. So we have to represent with sodium means capital S. But capital S represents sulfur. Capital S represents sulfur. But how to represent sodium then? So to avoid such type of confusions, they took the Latin names for some compounds, scientists names for some compounds. Again we have a different phenomena further. So sodium, it is Na. Where from this Na came? It came from the Latin name natrium. Sodium in Latin name is natrium. In that natrium, the first two letters N is the capital, A should be small. So sodium always we are representing with symbol Na. That Na came from its Latin name natrium. So actually what we are thinking that Berzelius introduced this symbols method, like, but before Berzelius, so scientists they have proposed different systems to represent elements, but they are not like as Berzelius method. Those were failed. So and they found difficult, because of that reason they were failed. This Berzelius method was easy to remember the symbols for the names. That's why it came into the light. Okay, it came into the application. Berzelius method only we are applying while writing the symbols, right students? Next, see, so now how to write the symbols like we have taken. Our next topic and very important one is atomicity of elements. Now we are representing elements with their symbols, right? Capital letters we are using, and one capital letter and second one is small letters we are using, and their Latin names also we are using for representation of the elements. What is the atomicity of element? First of all, see, the number of atoms present in one molecule of an element is called its atomicity. Simply we can explain this definition. Number of atoms present in an element gives its atomicity. Okay, this atomicity it classifies into different types. Means it depends on number of atoms present in that element. If only one atom is present in that element, those are called monoatomic elements. If two are present, diatomic, three are present, triatomic, four are present, tetraatomic, and more than four are present, that one we can take as a polyatomic. Poly represents so many. More than 4 actually we'll consider as a polyatomic. Even 4 also we can consider as a polyatomic. So let us see the different classification of the atomicity. First one is monoatomic elements. What is meant by monoatomic elements? The elements with only one atom in their molecules. Now see, whenever you are representing copper metal represents with Cu only. No Cu2, no Cu3, like that we are not representing. Individual copper element we are representing with single atom. That is nothing but only one atom will be present in that molecule. So this is called copper atom, silver atom, neon atom. Only one atom is presenting in that molecule. So these are called monoatomic. One represents mono. Okay. Next come to the diatomic elements. Diatomic elements means more than one. Two elements. Di represents two. If the elements with two atoms in their molecules, H2 molecule is there. Hydrogen is representing with H, but that is hydrogen atom. While representing the molecule, hydrogen molecule, if you want to represent, it will have two atoms. Two atoms combining and forming hydrogen molecule. H and H, H2. This is a molecule. Like that only O2 molecule. O and O, two oxygens are combining and forming O2 molecule. Next two chlorines are combining and forming chlorine molecule. Only two is possible. Hydrogen molecule means we'll write H2 only. We'll not write H3, H4, H5, like it will not form. Only hydrogen is diatomic in nature. So diatomic elements, the two atoms in their molecules are called diatomic. Examples are H2, O2, Cl2. Still we have F2. F2 is also one more example. F2, Br2, I2, N2, N2. Nitrogen molecule also diatomic molecule only. Okay, these are the some examples for diatomic elements. Now come to the triatomic elements. Now you can tell the definition. Triatomic. Only one atom is present monoatomic. Two atoms are present diatomic. Three atoms are present in a molecule. In their molecules are called triatomic elements. Oxygen. It is O2 means diatomic. Even oxygen forms triatomic also. That is called ozone. Ozone, depletion of ozone layer, like we study, right? That ozone, O3. Three oxygen atoms are combining and forming the ozone. It is oxygen. Oxygen is diatomic. Ozone is triatomic element. Okay, ozone is triatomic molecule, oxygen is diatomic molecule. O3, it is three oxygen atoms are combining and forming the O3 molecule, so it is triatomic. See, polyatomic molecules are polyatomic elements. Generally, the elements with two or more than two atoms in their molecules are called polyatomic elements. See, P4, phosphorus. P means phosphorus. Phosphorus can combine with four phosphorus atoms and forms a molecule. This is called phosphorus molecule. These elements, it is four are combining. It is called tetraatomic. Sulfur, it can combine 8 atoms of sulfur combining and forming S8 molecule. 8 means octa. This is octa atomic. Generally more than 3 or more than 2 are said to be polyatomic elements. So this P4 S8 comes under the polyatomic elements. Is it clear, students, that atomicity? Atomicity is nothing but number of atoms present in an element or a molecule is called its atomicity. Monoatomic, diatomic, triatomic and polyatomic elements with examples, right? Now come to the next one and very important one in the chemistry. If you understand valency clearly, the chemistry will be easy. That valency is that much important in the chemistry. So let us see what is meant by valency. See, during the formation of molecules of compounds, atoms combine in certain fixed proportions. See, during the formation of molecules of compounds, see, water is a compound. How to write water? We'll write water molecule as H2O. Wherever you write the representation, the chemical representation of water molecule is H2O only. There is no change. Carbon dioxide gas, carbon dioxide, wherever you write, that is CO2. One carbon, two oxygens, that is fixed. There is no change, that is called fixed proportion. While forming the compounds, that atoms combine with fixed proportions. Whenever the water to form, two hydrogens, one oxygen will give you the water molecule. When one carbon and two oxygens give you the carbon dioxide molecule. So that ratio of the atoms, the combining of the atoms is in fixed proportions. This is because of the fact that atoms have different combining capacities. That combining capacity of an element is called its valency. That combining capacity is called its valency. So how can we define the valency? The combining capacity of an element is called its valency. This valency is measured in terms of hydrogen atoms or oxygen atoms. See, the valency of hydrogen is taken as 1 and is selected as the standard of valency. Whenever the valency of hydrogen will be 1 only. That's why oxygen's valency is 2. Hydrogen valency is 1, oxygen valency is 2. Those are the standard valencies. Those we are taking as the reference valencies also, right? See, thus the valence of an atom element can also be defined as the number of hydrogen atoms which combine with an atom of it. The combining capacity of an atom is called its valency. And also one more definition for valency of an element by taking hydrogen as the reference compound is the number of hydrogen atoms which combine with an atom of it is called its valency of an element. Example, see, in methane, its molecular formula is CH4. Its representation is CH4. CH4 means methane. One carbon, four hydrogens. One atom of carbon combines with four atoms of hydrogens. So the valency of carbon is 4 because hydrogen's valency is 1. Like that, carbon is combining with how many hydrogens? 4 hydrogens. So obviously carbon's valency will be 4. See, H2O molecule is there. H2O. Oxygen is combining with two hydrogens. So what is oxygen's valency? 2. Because oxygen can combine with only two hydrogens. So the oxygen. So here we are defining the valency of oxygen with respect to two hydrogen. Here we are defining the carbon's valency with respect to two hydrogens. That is also one of the definition. Since all atoms do not combine with hydrogen. Yes, that is also the point. Or suppose NO2 molecule is there. Nitrogen is combining with hydrogen forming NH3 ammonia. Even nitrogen is combining with oxygen also. There is no hydrogens. Then how to define that one? That is what here we are explaining. All atoms do not combine with hydrogen. So the valency of element is also defined in terms of other elements like oxygen and chlorine also. Hydrogen, taking the hydrogen we can define the valency as usual. Oxygen also we can take, chlorine also we can take as the reference compound. See here it is the CH4 with respect to hydrogen. One carbon is combined with other four hydrogens. So the carbon's valency is 4. Hydrogen's valency is 1. Each hydrogen's valency is 1, 1. So 4 hydrogens combining with 1 carbon. So carbon's valency is 4. Now we have taken valency in terms of oxygen. In the previous we have studied valency in terms of hydrogen, right? Now we are studying valency in terms of oxygen. See here, how can we define valency in terms of oxygen? Valency of oxygen is 2, that we should remember, as in H2O, because oxygen can combine with only two hydrogens. Because of that reason oxygen valency is 2. We are taking that one as the reference. Double number of oxygen atoms with which one atom of an element can combine is called its valency. Suppose example, see calcium oxide. Calcium oxide. Calcium is combining with one oxygen only to form calcium oxide. Oxygen's valency is 2. So obviously one oxygen with calcium is combining. So calcium's valency is also 2 only. Suppose NO2. We will take as NO2. As we know, oxygen's valency is 2. But how many oxygen atoms are there? 2 oxygen atoms are there. 2 2s are 4. With respect to oxygen, nitrogen's valency is 4. Do you understand the point? One atom of calcium combines with oxygen, but oxygen's valency is 2. That's why we have taken even calcium is also 2. Like that only different examples we can take and we can explain. This is calcium oxide as the example with in terms of oxygen. We can go valency in terms of chlorine also. Can be defined number of chlorine atoms with which one atom of an element can combine, because valence of chlorine is 1. As valence of chlorine is 1, hydrochloric acid or hydrogen chloride, symbol is HCl. Here hydrogen's valency is 1, chlorine's valency is 1. Here you can explain with respect to hydrogen or chlorine. Hydrogen valency is 1, so it can combine with only one chlorine. So valence of chlorine is also 1. Right? Next. Example here they have given NaCl. NaCl. See NaCl. Chlorine's valency is 1. That's why it is combining with only one sodium. Now here sodium's valency is also 1. So this is with respect to hydrogen, with respect to oxygen, with respect to chlorine, how to define the valency of other elements in a compound. Now assumptions in finding valency of elements. See, assumptions in finding valency of elements. The valency of hydrogen and all metals is considered positive. Always hydrogen, when it is combining with metals, that hydrogen valency you should take as +1. When it is combining with non-metals, hydrogen's valency you should take as -1. When combining with metals, hydrogen's valency will be +1. These are the assumptions. As the molecule of a compound is electrically neutral, it assumed that total positive valency in its molecule is equal to total negative valency. Here, sodium chloride only as the example if you are considering. Chlorine is a non-metal, -1. Whereas come to the sodium is a metal, it is +1. So +1, -1, both are getting neutralized. Right? So +1 and -1, positive valency and negative valency should be equal. Then only we can say the one compound is electrically neutral like. We can take H2O as the example. If you take H2O molecule, H2O, oxygen is non-metal. When oxygen is non-metals are considering, expect hydrogen. Oxygen is non-metal, its valency is minus, so -2. Oxygen is -2. Then obviously hydrogen will be +1. But how many hydrogens we have? 2 hydrogens we have. So here it will be +2. +2 and -2. Positive charges and negative charges are equal. So H2O can be, we can say, electrically neutral compound. Not only this compound, every compound in the chemistry is forming should be electrically neutral. Then only that compound formula is possible. Other than that formula is not possible. That is the very important and basic thing. See, sometimes some compounds they'll show variable valency. Hydrogen +1 it is showing. Hydrogen showing -1 also when it is mixed with some metals. So, see, what is meant by variable valency? An element with more than one valency is called variable valent element. It has been found that certain metals exhibit more than one valency. Some metals are showing the different valencies while forming different compounds. Okay, so metals are said to be exhibit variable valency. How to name an element with two different valencies? Let us see, this is also very important and interesting thing. I'll take one example, that is, see here, it is Fe2Cl2 and it is FeCl3. Here iron is combining with two chlorine atoms. Here iron is combining with three chlorine atoms, isn't it? So as here iron is combining with two chlorine atoms, each chlorine is 1. So iron's valency is 2 here. Whereas come to here, iron is combining with 3 chlorines. Each chlorine's valency is 1. Then this iron's valency is 3. So in FeCl2 compound, iron's valency is 2. In FeCl3 compound, iron's valency is 3. Means what is that? Iron is showing two different valencies. That is called variable valency. Mostly metals shows this variable valency. But here, how to name these compounds? It is FeCl, it is FeCl2, it is FeCl3. How to name? See, the suffix "us" is attached at the end of the name of metal for lower valency, "ic" for higher valency. See here, it is FeCl2. Valency is 2, right here. Valency is 2. So we have to name this is as ferrous chloride. It is called Fe2 plus is called ferrous. Whereas come to Fe3, FeCl3, it is called ferric. Because here 3, ferrous iron valency is 3, higher valency. So ic, ferric chloride. Here iron valency is 2, lower valency comparatively. So it is called ferrous, ferric. This is one of the example for variable valency. Not only FeCl2, FeCl3, essence, tannum called, that is also SN, tin chloride, SnCl2, SnCl4. In that Sn also shows +2, +4. Stannous chloride, stannic chloride. as ik, lower valency as higher valency ik, like that we'll name the compounds ma. So this is some part of the language of chemistry, still more there to explain. So listen carefully, understand carefully, and thank you for watching our video. And please do subscribe to our YouTube channel Aims Today for latest updates and recorded videos. Okay, students, thank you so much.